Alright, welcome back to our second last lesson of our solutions unit, and this is where we're just going to be looking at very briefly the strength of acids and bases, because not everything is going to be a strong acid or a strong base. So we're just going to look at how we actually measure the strength of acids and bases. So as you can read right here, acids and bases can be distinguished from another by diagnostic tests such as litmus or pH tests, and of course that's and indicators and stuff like that we can all do. Now, acids with the same initial concentration can have different degrees of acidic properties. So that means different pHs, so we can have different acids at 1 mole per liter. And if we're comparing like hydrochloric acid compared to citric acid, they're going to have different pHs. And they can even have higher rates of reaction with magnesium or even lower rates. So of course, if you were to perform tests with these here, if you're to study them, it's very important to control variables such as concentration, temperature, and of course this is to obtain reliable results. So we already looked at empirical properties of acids and bases, but now we're just going to describe, weak acids and weak bases and stuff like this. So for an acid or base described as weak, the acid or base, its characteristic properties under the same conditions are less than that of the common strong acid or base. And of course, for our strong acids, we know there's 6 of them. For a strong base, we know it needs to be a metallic hydroxide, so like lithium hydroxide, sodium hydroxide, calcium hydroxide, and stuff like that. So we already went over the characteristics of acids. Now we're kind of have this exact same chart, is that now we're just comparing strong to weak. So as we know, strong acids, where they ionize completely, they have extremely high conductivity. So a weak acid is going to be something that's defined that has just less of that characteristic under the same conditions. So if a strong acid has high conductivity, a weak acid is going to have low conductivity. Now we already looked at or this is one of the ones as well, we know all acids react with active metals like magnesium and zinc and carbonates. So all strong acids have a high rate of reaction, so obviously if weak acids are going to have less of that characteristic, so they're going to have a low rate of reaction with active metals. So active metals are our magnesium and zinc, and our carbonates is just anything that has CO3 2 minus in it. Now, of course, for strong acids, they do have relatively low pHs, so closer to 0, like 0, 1, 2. Of course, for our weak acids, we're going to have higher pHs, closer to 7. Obviously, we can't go above 7 because then that's going to turn into a base. And if we're dealing with weak acids, they're not basic, they're just weak acids. So, of course, strong acids, the reason why they're highly conductive, the reason why they have such low pHs is they have many hydronium ions in solution. So, of course, our weak acids are going to have very few hydronium ions in solution. Our strong acids react completely with water to form hydronium, where our weak acids only react partially with water to produce our hydronium. Whereas our strong acids, there are very few. Remember, there's only 6 strong acids, and there are many, many, many weak acids. So basically, if you have an acid that doesn't fall within that strong acid category, it's going to be considered weak. So that is all the properties for the acids. Now our next chart, and this is going to be our last one, we're just going to look at the bases. So this is kind of the exact same thing as where we have our strong base and our weak base. So you can see how if a strong base is highly conductive, a weak base is going to be low conductivity. A strong base has a pH closer to 14, so extremely high pH, whereas a weak base is going to have a lower pH, so closer to 7 and stuff like that. Now remember, our strong bases are all ionic hydroxides or metallic hydroxides, whereas a weak base is a substance other than hydroxide ions. So for example, ammonia, carbonate, sulfate, and so on. So there's a bunch of different bases that can be that. Now, for a weak base, we've seen this with the modified Arrhenius theory, is that a weak base needs to react with water to produce hydronium ions. Now, because a strong base where it is hydroxide ions, these actually, they don't react with water, because remember, these dissociate. To produce. So that was one of the huge big differences when we did these here. So for example, in the modified Arrhenius theory, when we had a weak base, we had the base plus water produce hydroxide, and then whatever the entity was to help balance it, so just a transfer of the hydrogen, whereas for a metallic hydroxide, we had M, so M equals metal ion where we had a metallic hydroxide, it produced metal with whatever charge, and then plus OH minus. So it was a dissociation and not a reaction. So that is it for the strengths of acids and bases. It is a really quick one here, but you do need to distinguish a difference specifically to strong bases. They can be a little confusing, especially for this right here. Know the difference between which ones dissociate and which ones have to react with water. And then, of course, knowing that if you are comparing the difference between a strong and a weak, just remember all of the strong characteristics of either a strong base or a strong acid, and then know that a weak one is just going to have less of that. So that is it for this particular lesson. Our next one is going to be on polyprotic substances that we could see down there, and then that will end off our solutions unit. So I'll see you guys for the next one.